Okay, so let's take a look at this little baseball application. We've got this equation, negative 0032x squared plus x plus 3. Okay, now the tendency here is for kids to be like, well, you know, can I just type this into a calculator and or Desmos? And what we're trying to say is you don't need to. You don't need to because there's things that you know about this equation. First of all, not to state the obvious, but you know that it's a parabola. Now, that's important. You see x squared, like next year or 5 years from now, it's a parabola when you get x squared. You also have this negative sign out front. That's important. That means the parabola is opening down. Now, if the parabola is opening down, um, and maybe we know something else like its y-intercept, like its starting value, we could draw that. Okay, maybe you need a little guidance from the teacher, but we could draw a parabola that is related to this guy that's hitting a baseball. Now, do you see what I did already? I kind of put like the x and y axis on here. Sure, why not? Why can't we say that the x-axis is like the ground? But if I know that the y-intercept is 3, again, because I know some things about the 5-point method, and I know that it's a parabola that opens down, then part of today's lesson is for you just to agree and say, yeah, I mean, it would have to look like that. You don't need a fancy Desmos or a fancy computer to draw what we just drew there. It might not be drawn to scale. It's okay, because we're a heck of a lot further along than we were a few seconds ago. And that was all based on knowing that the parabola opens down and it has a y-intercept of 3. Okay, so now what? Can we maybe answer some questions? At what height is the ball hit? Okay, we were supposed to look at that and say, well, we kind of just figured that out because that's, of course, the y-intercept. If you look at the sketch that we drew, it would have to be. And so we can, with great confidence, we can say that it was hit at 3 feet, which if you're into baseball games, not a bad spot to hit a ball, usually right in that hitter's pocket. How about the maximum height? Question 2, the maximum height. Now we're getting a little bit more fancy because the maximum height is a point that we haven't found yet. But it shouldn't come as too much of a surprise that the maximum height has everything to do with the vertex. Vertex or vertices are pretty important to a parabola. And again, I want you to resonate. It's a maximum. A vertex is a maximum. Okay, so let's find the vertex. Okay, now to find the vertex, we don't have to throw out anything that we've learned. In fact, we just want to use what we learned. And that, of course, is the vertex formula. Can we do the opposite of b over 2a? Sure. Is it going to involve a decimal? Probably. But the opposite of b over 2a for this problem is going to be the opposite of 1. So x equals negative 1 all over 2 times, well, again, this decimal, negative 0032. Now be careful. This is kind of the part in the lesson where you can just kind of watch me, or you can actually do this on your calculator, but be careful. How do you type in negative 1 over 2 times negative 0032? For most of your calculators, kids, you're going to need to add these red parentheses because your calculator needs to know that you're dividing by that entire denominator. Try it, okay? It's exactly as I have it written here, but you're going to need that extra set of parentheses so that you can get 156. 156. If you're not getting 156, make sure that you're dividing by that entire denominator. Okay, so the extra parentheses. Now, what I really want to make sure you understand is that 156 is not the final answer. Say what? Well, 156 is the x value. 156 would be this distance. Again, the x value to get to the vertex. What we want is this y value. We want this red distance. Okay, so just like you did on the warm-up and just like you did on the homework, you do have to take that extra step and you have to plug in the x value. Now, it's a word problem, so it's kind of a pain because we have to plug in with some of these goofy numbers. But you definitely want to take 156, plug that in for x, so it gets squared. It also gets added. And don't forget about the plus 3 that's at the end of your equation. Now, again, this is a little bit of a word problem, so you have to navigate your calculator. You have to be okay typing in that entire formula. Try it, okay? You can just type it as it shows. It should come out to 81 and a little change. 81. If you were going to summarize what we just did for the last couple minutes, it's what we did yesterday. We found the vertex, but we want to know that the y value is actually the height. Okay, so the height is actually just the 81. The 156 would not really be your final answer, but it's used to get your final answer. Ready to try it? I don't want to say again, but let's take a look at another problem that uses some of these points on the parabola. Okay, similar situation. We have something that's being projected. In this case, it's being thrown. So we have a ball that's being thrown. Again, not to kind of like be redundant, but when you look at a problem like this, x squared says parabola, negative says parabola opens down. And we actually have the same y-intercept. What I'm getting at is that you can take these three things and you can draw a little sketch. Okay, people sometimes aren't comfortable with this because you're kind of making something out of nothing, but I'm trying to help you say that you know this. You know that it's a parabola that passes through the point 0,3. And honestly, it can look a lot like the problem that we just did. It can look like the problem we just did. If you want to draw a little kid throwing the ball, that's up to you. Okay, so we have another, at what height is the ball thrown? Just trying to get the idea that that's the starting height. That's always the y-intercept. Yes, it's the number 3 again. Maybe I should have made up another number, but 3 is working good. Look at question 2, though. A little different question. How far from the child does the ball strike the ground? How far from the child does the ball strike the ground? Okay, we're now looking for this blue distance. I want you to look at that question and feel like that your goal is actually to find, it's to find an x-intercept. Okay, so the ground is really the x-intercept, and of course that's one of our 5 points on the parabola. Now remember, to find an x-intercept, you want the equation to equal 0. Just like you did on the warm-up, when the equation's equal to 0, you can either factor it. Of course, I doubt it. I doubt you're going to factor a problem that has these types of numbers. Or you could pop that into the quadratic formula. quadratic formula is probably the way to go. Are you willing to try the quadratic formula even though you have a fraction in the equation? It's still going to be the opposite of b. Okay, it's still going to be opposite of b, so -4. It's still going to be plus or minus. Okay, now the square root of b squared minus 4ac, that's always lots of fun, but if you type in b squared minus 4ac, it should come out to be 18. Make sure that you can do that. Again, don't just take my word for it. And then all over 2a is going to be all over 2 times -1/6. Again, can you get 18? That's usually the defining number because, of course, that is b squared minus 4ac. Now, I think I have some good news for you. It's a little different than how we would have approached this yesterday. This is a word problem, and therefore we're actually looking for an answer, like an actual number answer. In other words, it's okay to get some decimals. So the square root of 18, it would be okay for you to change that to 424. Again, the square root of 18, instead of simplifying that, as we may have done in the past, you can just change it to a decimal. Because what we really want to do is we want to try to figure out what is -4 plus 424 and what's -4 minus 424. Now notice that they're both divided by -1/3. We kind of have this decimal or fraction down here, which is a bugger. But if you think about this, we're dividing by a negative, which means that I only want to get a negative in my numerator. Now, this takes a little forward thinking, but because I'm going to divide by a negative, I only really need to get a negative, that is the subtraction, in my numerator. And here's why. Because when I do the subtraction, and as I'm trying to say, when I do the subtraction only, I'm going to end up with a negative number. I'm going to get -824. And two negatives, when divided, make a positive. So what we're saying here is that I don't need to find both answers. So -8 divided by -1/3 is going to give me my positive answer, which is 24 and a little change, about 2472. Now, if you want to find both answers, you can, but you would only be finding the answer that's back here, which would kind of be like if the child dropped the ball or something. So we don't really need that answer. Instead, we only need the one that's positive. Okay, so it's 24 feet for that distance. When you're doing an application problem, it's okay to kind of think a little bit about what point or what points I really am trying to find. Maybe I don't need to find all of them. Okay, now we're trying to keep this kind of simple, so instead of throwing another problem at you, I want to encourage you to take a look at the homework helper. In fact, I wanted to give you a little time in class that maybe you could start one of those.